Hello friends, today we are going to learn how to simulate our VHDL module with ModelSim. So first of all, we'll open ModelSim. Oh, it may take a while. And so basically what we are doing is whatever module that we designed or whatever system we designed in VHDL, we are going to simulate our result. So see, we can just either you can from file also you can create a new project, otherwise here we have option. So let's look at where we'll keep our, let's say, okay, somewhere I selected documents, and then you select the location and then give the project name, like for example ALU test. Okay, I'm testing it. So now if I want to create a new file, you want to write the code entirely new, then you can go in create file, otherwise you can add existing file. So I'm going to, for example, now I'm going to do with the ALU. I have designed a ALU 8-bit ALU, so I'm going to test that. So I have already written the code, so I'll add the existing file. Okay, and I will locate it. So I have kept in desktop, so I have this alu.bhd file, right? So I'll open that, and here's the two options: reference from current location, that means that it will locate, otherwise it will copy to the project directory. So I'll copy it, so my original won't be changed. Okay, and then I'll close it. Now since you see I have loaded my BSD file here, I can even view this by double clicking. See, I can see the code. So this is my code that I'm going to simulate. So by double clicking I can view it now, but first of all, before simulation I need to first compile the code. So here is my option, compile selected. So you can see the transcripts here, what the process are going on, like compile is successful. So in the same way, now my compilation is successful. So if I want to simulate, then I guess it already has been included in my library's work directory. So my work directory contains that after the compilation. See the ALU code you can see here. So now for simulation, let's say we'll right click it and then select the simulate option, and it will take me to the simulation window. The new window will start up where that bench would be added. Okay, this is my code showing, I don't require it now. So see, already I have got this simulation, and I have clicked the simulation. So if I go to the simulation module, which will be, I guess, right here. See here, see, I got a new module where I can simulate now. Okay, so this window will come up, the new window, sim window. See, you can see from here, this sim window that is coming up, and that is very important. Now the main module is my ALU1. We generally select the main module. So what we'll do is add web. Add web means we are creating a new web, and we'll add this module to the web. So this is my add web, and you see I got a web where I can see the simulation. So I'll maximize it. Now from here, this was a signal that was not required for me, so I'll better delete it, or you can even see it. So I guess it will be better if I delete it. Not required. Only see the inputs are AB are the two inputs, 8-bit input, and opcode. The ALU has the opcode of 4-bit, and then I will see the output, the F, the output, and then carry and equal flags. So let's say what we will do now. After you have seen the inputs, now I'll force the values to check. Okay, for instance, let's say in hex, it's 8 bits, so 2 hex digits. So let's say 6 A. I have given input A, 6A value. Similarly, I can force here also. I'll force it here. For B, I like, let's say 8D. Okay, so I gave the value. Now I have in my 4-bit opcode, I have 13 different operations. I'll select any one and verify it. Let's say from 4-bit, so 1 hex digit would be enough. So 1 hex digit. See, you can see X written over there. So let's say I give it first I'll check 1, so my opcode will be 1, then 2, 3. Similarly I'll go on. So okay, now this is my here you can see it has at what interval you want to see the result, and then you have that is a run length, and then just at the center of that we have a run. So this is simulation run. So I'll click here. See, I got the result. So if you want it more clearer, then here we have a zoom button here. So zoom plus, you can click on that. Okay, but for now it's fine. For now I guess you are seeing it. So see, after giving input 6A and 8D, 2 inputs, and giving the opcode 1, I got the result DD. That is my result. Let's say of other inputs, other set of inputs. So after, I will not change A and B, I'll change the opcode to see the other results. What are my other results? So I'll force it again. Okay, so for forcing, let's say I want to check my operation 4. I have 13 different operations, although 16 can be made from 4 digits, but still I have done only up to 13 operations. So operation 4, let's say. So I have forced that value. Now I'll again simulate it. So I'll get another next pair of adjacent pair of waveform. So my A and B are constant, whereas I change the opcode value S4, and according to that, like my for example, my 1 was addition operation, so whereas my 4 is another kind of operation, which is subtraction operation. So I'm getting such kind of result. And similarly I can go on, I can, like, I have rotate, I have shift, a lot of, so that for checking that, now again I'll do, I'll right click it, okay, and again force, and I want to check my operation, let's say A, that is 10th operation. Okay, so I'll click it and I'll click that. So all the outputs are coming. So for the same set of input, my output. In this way you can simulate, go on simulating more and more, and finally you will find some kind of waveform. You will get some kind of waveform. You can check for all the possible combinations. Okay, so I have forced, let's say again I'll force let's say 8. So if I am forcing 8 and again simulating it, I'll get a different set of results. Okay, and I'm getting different set of results. Actually 8 and A gives the same result, so I can see here I have equal flag also. So let's check that also. Equal flag means if 2 inputs are equal, then what will happen? So in this time what I'll do is I'll only force like I have forced 6A here, in B also I'll force 6A, same value, and let's check that equal flag works or not. So simulation is basically for checking that your system is working properly or not. So I'll give the same input 6A here also, right? So let's check. Now we'll keep the opcode. Opcode doesn't matter. Now we want to check the flag, equal flag. See, now finally the equal flag is being high here. We get the value of 1. It means it is working. Okay, so in this way we can check whether our module that we have designed or the system that we designed is working or not. You can save it. If you press the and you want to save it, then you can save. You can keep your own name here. Do file will be created, which is also called micro file. Let's say ALU sim. So you can save it and you will get the file. And one more thing, okay, finally I want to tell you one more thing. We can even see the scripts being prepared. Like we can go to view, and what are the transcripts that are being prepared as we go on. So see, you can focus here. Like in the first step I had done, like I forced value 6A, then I forced B the value 8D, and so on, and I forced the opcode 1, and then I only changed the opcode next time, opcode to 4, and then A, and then 8, and so on, and then I again forced. So these scripts are being you can go with this command also. If you remember, if you practice the enough command, then from command only you can do those simulation as well. Okay, you don't have to. Same are the code generated. You can copy them and keep it somewhere and make a do file yourself also. But generally that is not suggested. You can save it here and you will get some kind of do file, that is the macro file. So this is about how we can simulate using the ModelSim. Thank you.